Okay, let's jump straight in. Today, we're taking a deep dive into uh, the real basics of statistics and graph work.
Yeah, looking at the source material you've got.
Exactly. And our kind of mission here is to pull out the key ideas, how we actually turn all that raw numerical stuff into something we can understand, something organized, maybe even visual.
And it's interesting where it all started. The word statistics itself, it comes from words meaning political state.
Oh, really? State.
Yeah, originally it was just about governments collecting numbers,
Mm-hmm.
population counts, land, that sort of thing. Purely state-driven data collection.
Right. So it wasn't just abstract math, it was practical, a tool for running things.
Exactly.
And the sources point out there's sort of two meanings for statistics, right?
There's the subject itself, all the methods, the principles for gathering, analyzing data.
Okay.
And then there's statistics, plurals, the actual numbers themselves, like economic statistics or sports statistics, the facts.
Got it. So the subject and the data. And data basically is just any set of numbers collected for a reason.
Pretty much, like that example in the source.
Yeah.
Student marks, 2, 8, 9, 7, 6, 5. That's your data, your raw material.
Okay, raw material. But just a list of numbers isn't always that helpful, especially if there's a lot. How do we start making sense of it?
Well, the first concept to grasp is the variable.
Variable, okay.
It's just something that, well, varies. A characteristic that changes from one person or thing to the next. Height, weight, age.
Right. Stuff that isn't the same for everyone or everything you measure. And there are different types.
Two main kinds the sources focus on, continuous and discrete.
Continuous. That's like higher weight, things that can be any value within a range.
Exactly. You could be 1.75 meters or 1.751 meters, or even more precise. Theoretically, infinite possibilities within a range.
Okay, and discrete.
That's for things that can only take specific separate values, often whole numbers. The classic example is number of children per family.
Right, you can't have 2.3 children. It jumps from 2 to 3.
Precisely. No values in between. And knowing that difference is, well, it's key for later analysis.
So we have our data. We know our variables. But the data's still raw, just a list. What's next? Organization.
Yeah, organization is crucial. You could sort the raw data, maybe lowest to highest. That gives you arrayed data.
A bit better, but still just a long list if you have lots of data points.
Exactly. Which is why tabulation is so fundamental, putting it in a table.
Ah, rows and columns. Makes it much clearer. Like that example table showing boys and girls in different families. Instantly easier to see patterns.
Right. And once it's organized, often the first thing you want to know is frequency.
Frequency, just how often something shows up.
Yep. Simple as that. In a data set like 12032154332bit12, the number 1 appears 3 times. Its frequency is 3. The number 2 appears 4 times. Its frequency is 4.
Okay, simple count. And putting those values with their counts together, that's a frequency distribution.
That's it. A table showing each data value and its corresponding frequency. Could be ungrouped, like listing each shoe size and how many people have it.
We're grouped. When do we need groups?
Usually when you have a really wide range of data, like test scores from 0 to 100, listing every single score might be too much.
So you group them, like 1 to 10, 11 to 20. Those are class intervals.
Correct. Class intervals. And you have to decide if they're inclusive, like 110 includes 10, or exclusive, where maybe 1020 means 10 up to, but not including 20.
Ah, that boundary issue. The sources mention an adjustment factor, like adding or subtracting 0.5 sometimes.
Yeah, that's often used to close the gaps between intervals, especially when you're drawing graphs later. Helps make things like histograms continuous. We also talk about class limits, the lowest and highest values in an interval, and the class mark.
The class marks, that's the midpoint, right?
Midpoint of the interval, yeah. Useful for some calculations in graphs.
And quickly, cumulative frequency.
Just a running total. Add up the frequencies as you go down a table.
Yeah.
Helps answer how many scored less than X questions.
Okay, so we've organized, we've counted, we've maybe grouped, but tables are still just numbers. Why graphs?
Because visuals just hit differently, don't they? A good graph can make a pattern jump out instantly in a way a table rarely does. More impact.
Makes sense. What are the key types the sources mention? I see histograms.
Right. Histograms are super common, especially for continuous data that's been grouped. You use rectangles side by side.
And the base is the class interval?
Base is the interval, and the area of the rectangle represents the frequency. So height matters, but width does too if the intervals aren't equal, and they touch, showing continuity.
Okay, and that kink sometimes on the axis?
Oh yeah, the zigzag. It just shows there's a break. If your data starts at, say, 50, you use a kink, so you don't have a huge empty space from 0 to 50 distorting the look.
Got it. And the other one? Frequency polygon.
Think of it like a line graph version of the distribution. You plot points, usually the class mark, against the frequency
Yeah.
and connect them with straight lines.
Can you get it from the histogram?
You can, yeah.
Mm.
Join the midpoints of the tops of the histogram bars. Then you usually anchor the line down to the x-axis on either side. Good for comparing multiple data sets on one graph.
So wrapping this up, these tools, variables, tables, frequency, histograms, polygons, they seem pretty foundational.
Absolutely. They're the basic toolkit for taking messy numbers and starting to see the story inside. Understanding these helps you, the listener, make sense of charts and reports you see everywhere.
It really does move from just raw figures to actual insight,
Mm-hmm.
which leads to a final thought for you to chew on. When you see data presented visually, maybe in the news or a report, how much thought do you give to how it's been grouped or drawn? How might those choices be shaping what you take away from it?